All right. So CloudStack is infrastructure as a service kind of product, similar to OpenStack and Eucalyptus. You spin it up, and it provides you the cloud management capabilities to call into an API and spin up and down nodes. So that's pretty cool, right? So now you can, host your own EC2 in your development closet or in your production environment or wherever you need to do that. So the cool thing, though, is like, let's say you have these apps, and they can respond to load. Let's say all of a sudden you've got a bunch of jobs queued up, and now you need more web servers or application servers or whatever. You can have an app that automatically, starts up new nodes by calling into this API. But how do you get your application config down onto these new VMs that were started automatically, maybe in the middle of the night when nobody's around, right? So you can use Puppet for that. So my goals when I was facing this challenge was I didn't want to use Puppet's auto signing feature, just because it opens a huge gaping security hole. So the instances, the VMs receive all of their configuration from Puppet. I don't want to maintain a library of different images, just because I don't like maintaining libraries of things. I want to maintain, one image, ideally, maybe two. And that goes right into minimizing the number of CloudStack templates. And when something launches a VM, I don't want any manual intervention whatsoever. A human shouldn't have to do anything. Makes your life easy, right? So, the long story short, make one API call, the VM comes up, and everything just happens. So why is Puppet's auto certificate signing bad? Anybody on your network who can now connect to your Puppet Master can now get a copy of all of your configs, and whether or not those contain critical information, MySQL connections, whatever, they can have at it, right? So how do you work around this? So what we decided to do was, because we controlled the templates, or in this case, what you can think of as an Amazon machine image, because we controlled the templates these VMs are being spawned from, we can go ahead and bake a pre-signed certificate into those templates. So that way we don't have to worry about either manually signing the certificate or having somebody spin up a rogue box on their desktop and connect into our environment and automatically getting a valid certificate. There are a couple of problems that we ran into when doing this. The first thing I did was change the cert name on one of the clients and generated a new cert. So the cert was called Compute001. But immediately after I did that and checked into the Puppet Master thought the node name was Compute001 instead of whatever host name I had on there. So you have to modify the config a little bit to tell it to use the fully qualified domain name as the actual node name. So pretty easy hack there to get it to work. And then you had to change one thing on the Puppet Master. On the Puppet Master, there's an auth.conf file, and it's basically telling you what nodes are allowed to retrieve from the Puppet Master itself. I had to comment out this top part here that was basically restricting nodes to only be able to download their own catalog. What I had to do was open it up so that any node could download a catalog from any other node as long as it had a valid certificate. And the reason why is outlined in that issue in Redmine, that 2128. So the next thing you need to do to be able to get these machines to check into Puppet automatically is make sure that when you're building your template, before you tell CloudStack to turn it into a template, is to turn off splay. So for those of you that don't know, splay is a setting that allows you to set a random delay from the time the Puppet Master or the Puppet agent starts until it checks into Puppet for the first time. So it makes it so that if you restarted Puppet on 100 nodes, they wouldn't all check in and DDoS your Puppet Master at the same time. But in our case, what that does is it now introduces a random interval from the time I launch my machine until it checks into Puppet and gets its config, and I don't want that, so make sure to turn that off, and make sure you tell Puppet to start on boot. So now that I have a machine that has a valid certificate and that is configured to run Puppet automatically, how do we get all of the machine's flavoring into it? I usually do this with a role fact. I like to set, some information in there, and I can use that in my manifest to determine what configs to push down to a box. So CloudStack and Amazon, and I assume OpenStack has a similar facility to store user data. User data in CloudStack is you can store up to 2 kilobytes of base64 encoded data, and that can be whatever you want, and it's associated with a particular VM. And the VM has access to this user data. It can talk back to the CloudStack virtual router, which I won't really talk much about that. But needless to say, if the VM needs it, it can grab that information and do all sorts of things with it. So what I decided to do was stick key value pairs, just as text into this user data, base64 encoded, and then when my Puppet client comes up, I have a custom fact that talks to the virtual router, grabs that data, parses it out into individual facts, and now I'm golden. And that particular snippet of code is available on my GitHub.
I got a question.
Yeah.
So this role or this user data set, is there any commonality between a bunch of machines in that data set? And do you audit that across all those machines on a regular basis, or is there?
Yeah, you could if you wanted to. Currently, via the CloudStack API, there's no way to read the user data, which is kind of a bummer. It's a limitation. I actually implemented a hack to their API so that I could read it via their API. But you could, if you wanted to, do something across all of them or audit that information. Because I'm loading all of the user data into facts, I found it much easier to use mcollective to audit that type of information. So now that we have...
Oh, we had another question.
Yeah.
The key value store, is that on the client, or is that in a memcache somewhere that you're...
The way it's implemented in CloudStack is for every availability zone and every network within an availability zone, they bring up with a software, a system VM called their virtual router. Mm-hmm. And on that virtual router, they're running a version of a copy of Apache. And so basically, you just connect in and send a wget over to that virtual router, and it figures out who you are by what IP you're coming from because it handed you your DHCP lease. So it knows who you are. And it sends all the data back to you. And it sends it to you in plain text. It's pretty simple. So now that we can load all those things up into facts, how do we use those? The way I implemented it, and there's probably a better way, all of my nodes are default nodes. That means I don't have to go to nodes.pp and add a node declaration. I don't have to go to my external node classifier system and put anything in there. All of that data is loaded via facts. So that's, this is my stripped down site.pp. Basically, every node is default node. And I'm including this manifest called base. So what's base look like? So base is really just a gigantic case statement. Up at the top, I might have things that I include to all of my nodes, like maybe my SSHD configs, my DNS servers, things of that nature. And then I have a giant case statement that says, hey, if you're role A, apply this particular manifest or set of manifests. If you're role B, go do something else. So you can also set a node's environment in a similar fashion. There's a kind of a catch, though, and they kind of hinted at it earlier. When you set the environment via the user data, it's kind of a chicken and egg scenario. The first thing Puppet does when it runs is, if you have plugin sync enabled, which you would have to do for my particular implementation of the custom fact for the user data, when it's connecting to sync over the fact, the custom fact, it doesn't know what environment that node belongs to, so it's going to default to whatever's specified in puppet.com. And if you don't have anything specified there, it'll default to production. So usually it's not that big of a deal, but it is a problem when you're testing new facts and new modules and new types and providers and things of that nature. So it's not really, it's easy to work around, but just know that there is a little catch there. So the cloud is pretty cool because now you can spin machines up on demand, but what happens when you destroy those machines or you no longer need them? Exactly. So let's say that you're automatically adding your nodes into Nagios via stored configurations, which everybody should be if they're not. Or via PuppetDB, right?
Absolutely.
Yeah. So that's what we'll be doing next week.
Just to clarify for people in the audience, store configs is a way to pass resources from one node to another node. So your web server can say the Nagios machine should have an HTTP check to make sure I'm running successfully.
Yep.
Yeah, exactly. But now we're running in the cloud, and so we kill a box, we kill an instance, and now our phones are blowing up because you killed a box and all the service checks are going off, right? So how do we avoid doing that? So really, what you want to do is remove that node from your monitoring system before the notifications get sent out. So the way I've managed to do this is I have a script that I run on my Puppet Master that talks into my cloud and says, okay, give me your list of instances that are still running. And then I compare that with the list of hosts that are in my stored configurations database. And if there are any hosts that are no longer in the cloud that are no longer running, I just say, okay, it's time to purge them from the Puppet database. And Puppet provides a couple of ways that you can do this. The old way, there was a script called Puppet stored config clean.rb that used to ship with Puppet. It's no longer shipping as of 2.7.14, I believe. Yeah. And the new way is to use Puppet node clean, and I'm pretty excited about that. I haven't implemented it yet using this new command, but it looks pretty cool. Yeah. So there's a script to do this cleanup to call Puppet stored config clean the old way on my GitHub. So that removed it from the Puppet Masters database, but that resource still exists on your Nagios host, right? So how do we clean that up? And this was kind of a limitation of my old system wrapped around that Puppet stored config clean script. I had to write another script that would connect to the Puppet Masters database and say, okay, give me your list of hosts, and then if there wasn't a host, if there was a host on the Nagios system that wasn't in the database anymore, then I cleaned it up there. But there's a more elegant solution, and I'll be working on updating my code here soon. So Puppet node clean has an option where you can, instead of removing it from the database, you can tell it to unexport any exported resources. So that's pretty cool, because what that means is, let's say you destroyed your node, you run Puppet node clean on it, and it unexports that Nagios host resource, right? So the next time your Nagios server checks into Puppet, it's going to see that that resource has been is now set to ensure absent. It's going to remove it from the host, and you can have it bounce Nagios for you.
Whoa, wait a second. So it doesn't actually unexport it; it actually sets it to ensure absent.
Yes.
Oh, that's awesome.
Yeah, it's pretty cool. So I just caught that. I haven't had a chance to implement the code to do it yet, but it looks really promising.
Does it clean the certificate in the master?
Yeah, it cleans up the certificate on the master as well, and I think it does a couple of other things too. It cleans up like the YAML files on the master. Removes everything that you no longer want hanging around after you don't care about a node anymore. So that's kind of an awesome feature that I have yet to play with. And I'm sorry for kind of rushing through this, but if you want, this presentation is available on my GitHub account. The URL got kind of truncated, but just go to here, and you can find it. And there's links throughout the presentation to all of the code that I talked about and all of the good stuff there. So, do people have any questions about CloudStack or running Puppet on CloudStack?
I was going to ask, we manually manage our Nagios configs. Is there a how-to guide versus the resource type
documentation on how to set that up?
Absolutely. There, if you Google like Puppet stored configurations Nagios, there are some great write-ups out there about how to do it.
And essentially, everybody that implements stored, like every walkthrough I've ever seen of stored config is how to do this with Nagios, because this is like the #1 thing you want to do.
Yeah, it's either Nagios or known the known host keys, the SSH keys. Yeah.
Okay, so a couple questions. So first off, in Nagios, one of the things I ran into in an older world in 2.4.8 was that the Nagios resource types were really intensive. So like my Nagios box would actually only complete a Puppet run maybe once a day, where the compute just happened to be right. One of the ways I addressed some of that early on was I broke them out into separate files. But I see this issue even on the latest Revit 2.7 where, so I create a file, and then I create the hosts that go inside that file, because I was removing manually, so I just wanted to gank a file and be done with it. Do you see issues with ordering where even though you're telling the Nagios host that it depends on this file, it's the Nagios host will complete as true, but the file won't exist yet? So it doesn't, like there's a host and a service, and like the file won't exist yet, so the host doesn't make it, but for some reason the service does, and then you get broken Nagios goodness.
I haven't seen that in my case. I generally don't export the services themselves as exported resources.
Okay.
I usually tie services to host groups and manage those manually via a flat file.
Okay.
And then I just make sure that when I'm declaring my Nagios host that's exported, that I put it in the right host groups.
Okay.
But I do split it out so that each host is in its own individual file in like a host.d directory for Nagios.
Okay.
Any other questions?
Questions?
Yes.
Oh, they can go first.
Question for Dave. You have a question? Question?
What's the end of it?
I believe it's just presentations.
Because it says move along. Nothing here, move along.
Yeah, I haven't committed it to GitHub. As soon as I sit down, I'll push it up.
Deepak?
No, I can go last. This gentleman here has one.
So you were talking about how you hit your API, your Cloud's API, and these instances are missing. I'll get them out of Nagios. I mean, sometimes in these cloud infrastructures, you kind of expect instances to just go away, but you kind of want to know that happened. Like,
Sure.
So how do you balance that?
So I would. So I'm looking specifically at nodes that have been destroyed, that the state has been set to destroyed or terminated. And I'm not necessarily looking at nodes that are stopped or anything like that. So the big thing for me is when I'm only pulling nodes out of Nagios that have been physically destroyed. Either somebody went in and manually clicked, okay, terminate this instance, or one of my provisioning apps decided to spin it down for whatever reason. So does that answer your question?
Yeah. Right.
Yes.
Mine was, how many, do you have any ideas around like the number of sort of systems or the number of resources that you're managing in your store configs database?
So it's pretty small. So I have thin stored configurations turned on.
Aha.
Yeah, that was the trick, because I learned my lesson way back in 0.25,
Yep.
whatever, where I brought down my my SQL server and all of that good stuff.
Gotcha. Okay.
So yeah, so I get around it by enabling thin stored configs.
Okay.
Any other questions anyone's got?
Yes.
You mentioned about database. So Puppet needs a database to work with?
It doesn't need a database by default. It's an optional option that you can turn on. If you want to use stored configurations, you need some sort of a backing store, and you have several options available. By default, it's a SQLite database. I chose to use a MySQL database, but I will be moving to PuppetDB next week.
And yeah, that is absolutely optional. Without store configs backend configured, you don't have store configs. We'll simply say, tried to use them, can't work, sorry, until you turn them on. But if you don't use the feature, you don't need the backing store or engine drive.
At what stage you opt to use the MySQL database? I mean, if you are 10 nodes, you don't need it, or 100 nodes, and and it will
Like,
The answer is as soon as you, for your business to manage your systems, need the capability it enables. So we have customers who have 15,000 nodes and do not use store configs. We have customers who have 5 nodes and do. It's not a size or scale or performance consideration. It is a what you want Puppet to do consideration.
yeah, if you want to use the information from one node to configure another node, then you would need to have some place to store all the information about all your nodes. But if you don't want to do that, then you don't need it. And for what it's worth, I'll be talking about that in like an hour. But
all my nodes are identical, then I don't need it.
it depends if you want to use the config. They can be identical. Like you could have 100 application servers that you want monitored, right? But to set up your monitoring server, you need to know what's going on those 100 servers. So even though those 100 servers are identical, you still want to use the information about them to configure a different one. So anytime you need to exchange information, you have to have some place, some medium of exchange, some place to either temporarily store it or do it live. But because Puppet can run at different times on different hosts, we can't really do it live. So you need some place to keep it. And that's any of the backing stores.
The reason I use stored configurations is I don't want to waste time having to manually configure Nagios for every single host in my environment. And it doesn't really work when you're in the cloud because you're spinning up and down instances on demand, and I don't want to spend my day managing a Nagios configuration. I want it to manage itself.
And so, back to your question, the 2 most common reasons people start using store configurations are I want to use Nagios or something like Nagios to monitor my systems, and I want to back up my systems. Spinning up a new machine and having it turn up in your monitoring system and in your backup system immediately with no human intervention is one of those great time savers. It saves you all that time looking for a new job because you forgot to configure backups for this host.
And a third use case that I see a lot too is adding nodes to load balancer pools and things of that nature. You can have a node come up, it starts up all the apps, and it automatically adds itself into the pool and starts serving production traffic.
Yeah, we did similar things with like firewall rules too, where the goal was, okay, anytime this setup happens, if this needs to talk to this class of machine, these firewall rules get exported and it fires up the firewalls or pokes holes in the firewalls as necessary.
So there's a lot of places you might use them. The big 2 are monitoring and management, and then these are the common steps through load balancing, firewalls, network infrastructure, distributed applications. But most people start out with monitoring or backups.
Yes.
Why CloudStack over, say, OpenStack or Eucalyptus or several other standards?
At the time that I was at, the time that we were building our cloud, I was at a large movie company, a movie studio here. We had already made the purchasing decision for hardware, and we already had some in-house talent that was very comfortable with one particular hypervisor. And those 2 decisions drove us away from OpenStack and Eucalyptus.
Sure. Which hypervisor?
VMware. Yes. So it was VMware, and we picked, for our compute nodes, we picked diskless Dell blades. And at the time, OpenStack was only supporting ESXi if you had local storage. And Eucalyptus at the time was still on their 2.x release, and they didn't have support for ESXi 4.1. And we couldn't go back to 4.0. We depended on some of the features in 4.1. But when I left that movie studio, we were VMware, and we had just started spinning up a Zen server zone as well.
Any further questions, anyone?
Just which platform are you using for your presentations?
It's Impress.js. It's available out on GitHub. It's all CSS3 and JavaScript.
Well, thank you very much.